So this is my video for the robotic arm project for Dr. Marpaung's class in EECE 2160, Embedded Design, Enabling Robotics. So my name is Daniel Klevak, and this is what I did for the project. So for this project, the problem that we were trying to solve was that we wanted to make the robot programmable so that it could move manually and automatically, and it would be able to lift and move a water bottle from one position to another. And this was done using Cordis Prime to design the schematic that would program the robot, and the DE1 SoC, which was what ran the Cordis design and controlled the robot. So the way that I decided to control my robot was I used these switches and buttons. The robot comes with 5 parts: the base, bicep, elbow, wrist, and grip, a lot like a regular human hand. So the base was controlled using just these 2 buttons on the right here, and by clicking those you could make it move back and forth within a 180-degree range of motion. And then to control the bicep, elbow, and wrist, these second 2 buttons were used in conjunction with the first 3 switches. So these switches were responsible for deciding which part of the arm actually wanted to move. So if you click the first switch, it would move just the bicep. If you click the second switch, it would move just the elbow. And if you click the third switch, it would move just the wrist. And then once these are clicked, you use these buttons to actually move the part. So when you can click multiple of these switches at once, and it would move any part that's clicked at once together. So if all 3 were clicked, then clicking these 2 buttons would move all 3 parts: the bicep, elbow, and wrist. The grip we did not have to worry about for manual movement because it was only lifting and dropping an object. So that was programmed in conjunction with when it was moving from position 1 to position 2. So the way that was done was when the robot is in the first position that is desired, then you would click this switch here, switch 7, and then that would save the first position. And then when you move the robot to the second position that is desired, you would click switch 8, and that would save the second position. And then it would still be capable of automatic movement, or of manual movement. But once you click switch 9, it automatically starts moving between position 1 and position 2. So what I did for the grip for this was that the grip would automatically close at position 1 and open at position 2. So it could pick up the object at position 1 with the closed grip and then move it to position 2 where it would drop the object. So yeah, and of course once it's moved back to position 1 from position 2, we don't want the water bottle to drop. So to solve that, it was programmed in that the wrist would raise automatically after dropping the bottle and then moving it to position 1, so that when it's moving away, it would not knock the bottle over. So this is what my circuit looked like for this project. It's kind of hard to read, but I'll try my best to explain the different components. So these top 2 blocks here are a counter and a comparator. So that's what was used for the pulse width modulation. And then this counter is what was basically everything else was based on. So to move the other components, we have these blocks here, which would change the value that the million counter is comparing to. So that way it would change the pulse width to move the arm. So these three blocks here are responsible for the bicep, elbow, and wrist. These 3 blocks here are responsible to move the base. And then once you go down here, all of these blocks here are responsible for saving the positions and then moving them and then alternating between position 1 and 2 or alternating between manual control. And to do these alterations, a mux was used, or these muxes were used here. So now we can see my robot in action right now. Program the device. Turn on the bot. Goes straight up to 90 degrees. Using key 0 and key 1, I can move the position of the base. Then using key 2 and key 3 in conjunction with switches 1 to 3, I can control the different components of the arm. So using this, I'm able to control, and I set position 1, and using by clicking switch 7, and by using the base buttons, I could Set position 2.
We want to make the mouse up the way as well.
Yeah, and then by clicking switch 9, I can have the robot alternate between positions 1 and 2 with ease. As you can see, the robot raises the wrist at the end so as to not drop the bottle when completing the task.